Hello friends and welcome to the session on industrial engineering. The topic for today is assembly line balancing. I am Professor V. Khond from Kekewa College of Engineering, Nasik. So the basic question, assembly line balancing. So for the assembling line, assembly line refers to the progressive assembly linked by some material handling device. So for this case, some things being required. So that is the first thing is the material handling device that we require. That may be a belt or roller conveyor, overhead crane, and so on. Okay. Another thing consider is the line configuration. It may be U shape, it may be straight, it may be branching. Then the next thing is pacing. It may be automated pacing or it may be manual pacing. Okay, or we can say it is a speed. So the next one is the product mix. So it may be a multiple product, it may be a one product, and so on. It may the next thing is workstation characteristics. So workstation characteristics includes workers may sit, stand, walk with the line, or ride with the line. Okay. Another thing is length of the line. It may be few or it may be many workers. Okay. The next thing is the range of the products or the partially or completely assembled on lines includes toys, appliances, auto, vehicle, that is the thing, clothing, and the wide variety of electronic component. Okay, so for any particular assembly line, there may be the different products that can be assembled. Okay. Next, the basic question, that is the assembly line balancing problem. So in the assembly line balancing problem, so it is the one of the assigning all the tasks to a series of workstation, so that each workstation has no more than can be done in the workstation cycle time, so that the unassigned, that is the idle time across all stations, can be minimized. Okay, so the thing is that we have to assign the task to the different workstations. So that is the assembly line balancing, so that the our cycle time can be achieved. Okay, the steps in the balancing and assembly line are: so initially, with the given data, you have to draw the precedence diagram, then calculate workstation cycle time, that is C, which is equal to production time per day upon required output per day. Then the third one is determine theoretical minimum number of workstation satisfying the criteria, so which is equal to NT, which is equal to sum of task time T upon cycle time C. Okay, then you have to select the rule. So there are three distinct rules on which the assembly line can be balanced. Okay, then you have to assign the task to the workstation. Then you have to determine the efficiency of balance. So efficiency will be equal to sum of task time T upon actual number of workstation multiplied by the cycle time C. So after efficiency calculation, if the efficiency is found to be unsatisfactory, in that case you have to rebalance using the different rule. So there may be the different rules. So select the rule, again assign the workstation, determine the efficiency, and see the efficiency is satisfied or not. Okay, then consider the example. So in the example, what we have taken is we have taken the work elements, we have taken different work elements. The element description is like this. So basically a kind of assembling. Okay, so these are the task time point 2, point 4, point 7, and these are the precedence. So we can see for activity number 1 or element number 1 there is no precedence, for 2 there is no precedence. That means it is individual, these two elements are individual. But for element number 3, it depends upon the work element 1. So unless and until element 1 is being completed, 3 cannot be started. So that is what the thing. Okay, so okay, so like this. So for element 2, it may be 4, 5, then 4, on 4 it is 8, on 8 it is 9 and 10, then for 9 it is 11, then 12. So for 2 it is 4, 5, 8, 9, 10, 11, 12. Okay, like this. Okay, so we got the balance delay as per 13%. Okay, now we have got the other ways to improve the line balance. So in the other ways to improve the line balance, so first thing is you have to divide the work elements. Okay, division of the work element. So let us say, for example, drilling a deep hole at one station was to cause a bottleneck situation should be separated into two steps. So in that way we can eliminate the bottleneck and increase the tool life. Next thing, you have to change the work lead speed at automatic stations. Okay, then you have to go for the method analysis. So we can have the method study. So for having the better workplace layout, design tooling or and fixturing, and improved hand and body motions. Then the next one is pre-assembly of the component. You have to reduce the total amount of work done on regular assembly line by another assembly cell or by purchasing. Okay, then the next one is, so you can have the inventory buffers between the stations. Then use of parallel stations. So disregard the stations must be arranged sequentially. Okay, so for example, by the arrangement of the parallel stations, so let us say this is the example. Let's say we have got the 5 station line and had a process time of 1 minute at all, but but the fifth station is of 2 minutes. So what is the fifth station? So here we have taken 4 stations, 1 2 3 and 4 station. Then what is the fifth station? Fifth station is of 2 minutes. So that means we have combined assembly station 1 and 2, that will become a kind of fifth station. Okay, so that way, so initially the production rate is this one, now the production rate is this one after having the parallel station. So use it to improve the line balance. So in the conclusion we can say that for the assembly line balancing there are the 3 rules that you have to use it, and you have to just see whether the efficiency is satisfied or not. If the efficiency is not satisfactory, you have to choose another rule, or you have to go for the another line balancing method. So let us say this is the reference for my presentation, and thank you.